Welcome to Farmtips Diary. A century ago, chickens took 4 months to reach market weight, and cows produced a fraction of the milk they do today. This is the story of how livestock evolved, what we gained, what we sacrificed, and where we might be headed next. Engineering the perfect cow in 1925. A dairy cow produced around 4,000 pounds of milk per year. Today, elite dairy cows in the United States produce over 23,000 pounds annually. Some exceptional animals exceed 30,000 pounds. This isn't a small improvement. It's a complete biological redesign of what a cow can do. This transformation began with systematic breeding. Early 20th century farmers chose bulls based on the performance of their daughters, a slow but effective method. By mid-century, artificial insemination revolutionized cattle genetics. One superior bull could father thousands of offspring instead of dozens. This concentrated genetic improvement across entire populations within a generation. Dairy breeds diverged dramatically from their ancestors. Holstein Friesians, already bred for milk production, became hyper-specialized machines. Their bodies were sculpted toward a single purpose: converting feed into milk with maximum efficiency. Breeding focused on udder capacity, milk composition, feed conversion, and longevity. Every trait was measured, recorded, and selected, but this specialization came with costs. Modern dairy cows are metabolic athletes pushed to their biological limits. High-producing cows burn through so much energy that maintaining body condition becomes challenging. Lameness, mastitis, and reproductive issues increased as production soared. The same breeding that made cows more productive also made them more fragile. Beef cattle followed a different path, but with similar intensity. Breeds like Angus, Hereford, and Charolais were refined for meat production. Growth rate, muscle development, and feed efficiency became the holy grail. Cattle that once took 3 to 4 years to reach slaughter weight now finish in 14 to 18 months. Marbling, the intramuscular fat that makes beef tender and flavorful, became a breeding target. Japanese Wagyu cattle represent the extreme end of this spectrum, with genetics selected over centuries for intense marbling. These animals are genetic outliers, but their influence spread globally as breeders sought to replicate that tenderness and flavor. The pharmaceutical industry also transformed cattle production. Hormones that promote growth and milk production became standard tools. Antibiotics prevented disease in crowded feedlots and improved feed efficiency. These interventions boosted productivity but sparked debates about food safety, animal welfare, and antimicrobial resistance that continue today. Modern cattle exist in systems their ancestors would find unrecognizable. Dairy cows are milked 2 or 3 times daily by robotic milking machines that monitor milk quality, detect disease, and optimize nutrition automatically. Beef cattle finish in feedlots consuming carefully formulated rations designed by nutritionists. These aren't farms in the traditional sense. They're biological factories optimized for efficiency. Yet efficiency has environmental shadows. Cattle produce methane, a potent greenhouse gas, through their digestive process. The more productive a cow becomes, the more resources it requires. Industrial cattle farming consumes vast quantities of water, grain, and land. The environmental footprint of beef and dairy production is now a central concern in climate discussions. The transformation of pigs and poultry. If cattle breeding was dramatic, what happened to pigs and chickens was a complete revolution. These animals changed so profoundly over the past century that a farmer from 1925 would struggle to recognize them as the same species. Start with pigs. Traditional breeds like Berkshire, Tamworth, and Duroc were hardy animals that foraged, produced lard as well as meat, and took 6 months or more to reach market weight. These were multi-purpose animals adapted to diverse farming systems. Then came the demand for leaner meat and faster growth. Breeding programs focused ruthlessly on specific traits. Litter size increased so sows could produce more piglets per year. Growth rates accelerated so pigs reached market weight in 4 months instead of 6. Carcass composition shifted toward lean muscle and away from fat as consumer preferences changed. Feed conversion improved so each pound of pork required less grain. The result is the modern commercial pig, typically a hybrid combining traits from multiple breeds. These animals grow with startling efficiency, converting feed to meat at ratios that would astound earlier generations. But they're also highly specialized. They thrive only in controlled environments with precise nutrition, climate management, and health protocols. Poultry transformation was even more extreme. In 1925, chickens were backyard animals that provided eggs and occasional meat. They grew slowly, laid sporadically, and required minimal management. A chicken might take 5 months to reach 3 pounds. Today's broiler chickens reach 6 pounds in just 6 weeks. This isn't an exaggeration. Modern broiler chickens grow so fast their skeletons sometimes struggle to support their muscle mass. Heart and lung issues arise because organs can't keep pace with body growth. These are the unintended consequences of breeding animals to grow at unprecedented rates. Layer hens experienced similar but different changes. Instead of laying 100 to 150 eggs per year like heritage breeds, modern layers produce 300 or more eggs annually. They've been optimized for continuous production, with lighting, nutrition, and environment carefully controlled to maintain laying cycles. The shift from small holdings to industrial operations happened with breathtaking speed. In the 1950s, most American families raising chickens kept a few dozen birds. By the 1970s, poultry production had consolidated into massive operations, housing tens of thousands of birds in single facilities. This industrial model spread globally, transforming chicken into the world's most consumed meat. Similar consolidation occurred in pig farming. Family farms with a few dozen pigs gave way to concentrated animal feeding operations with thousands or tens of thousands of animals. These facilities achieved economies of scale that small producers couldn't match. Efficiency soared, but so did concerns about animal welfare, environmental pollution, and rural community decline. The genetics of growth. Behind these physical transformations lies a century of genetic selection that rewrote the biological rules governing livestock. Early breeders worked with visible traits and performance records, making slow but steady progress. Modern breeders use genomic selection, analyzing an animal's entire DNA to predict which individuals will produce superior offspring. This shift from phenotype to genotype accelerated improvement exponentially. Instead of waiting to see how an animal performs or how its offspring turn out, breeders can evaluate genetic potential at birth. This cuts generation intervals and increases selection accuracy simultaneously. For cattle, genomic selection improved traits like milk yield, disease resistance, and fertility. For pigs, it enhanced litter size, meat quality, and feed efficiency. For chickens, it pushed growth rates and egg production to levels that would have seemed impossible decades ago. But genetic improvement created biological tensions. Animals bred for extreme productivity often sacrificed overall robustness. Dairy cows that produce enormous milk volumes have shortened lifespans. Broiler chickens that grow at extraordinary rates face leg problems and metabolic stress. Pigs with large litters sometimes struggle to nurse all their piglets. These trade-offs raise fundamental questions about the limits of animal breeding. How far can we push biological systems before unintended consequences outweigh gains? Is faster growth worth the health problems it creates? Should productivity be the only goal? Or should welfare and longevity carry equal weight? Some breeding programs are reversing course, incorporating welfare traits alongside production metrics, selecting for stronger bones in broilers. Breeding dairy cows for longevity and disease resistance, not just milk volume. Developing pigs with better mothering abilities alongside litter size. These efforts acknowledge that sustainable livestock improvement must balance multiple objectives: husbandry, technology, and welfare. Livestock transformation wasn't just genetic. The way animals are raised, housed, and managed changed as profoundly as their biology. Traditional farming involved pastures, mixed crop livestock systems, and relatively extensive management. Modern livestock production moved increasingly indoors into controlled environments designed for efficiency. Dairy cattle transitioned from pasture-based systems to confinement facilities where every aspect of the environment is regulated. Feed is delivered via automated systems. Milking occurs in parlors or with robotic milkers. Climate control maintains optimal temperature year-round. This level of control allows for precision management unimaginable a century ago. Beef production split into two phases. Calves start life on pasture, then move to feedlots for finishing. These feedlots can house tens of thousands of animals in pens, where they consume high-energy rations designed to maximize weight gain. The efficiency is remarkable, but so is the concentration of animals, waste, and environmental impact. Pig and poultry production adopted similar models. Broiler chickens grow in climate-controlled houses with automated feeding, watering, and ventilation. Lighting programs manipulate day length to optimize growth. Sensors monitor temperature, humidity, and air quality continuously. The entire process is engineered for consistency and efficiency. Layer hens live in various systems, ranging from battery cages to cage-free barns to free-range operations. battery cages, where hens live in small wire enclosures, maximize space efficiency and egg collection, but severely restrict natural behavior. Consumer pressure has driven some producers toward cage-free or enriched systems that allow more movement and natural behaviors. These intensive systems enable the scale and efficiency that make meat, milk, and eggs affordable and abundant. They also concentrate waste, disease risk, and animal welfare concerns. The ethical debates are genuine and unresolved. How much do we prioritize low food costs versus animal welfare? What responsibilities do we have to the billions of animals in our food system? Technology continues reshaping husbandry practices. Wearable sensors monitor individual animal health, detecting illness before visible symptoms appear. Automated feeding systems deliver customized rations based on each animal's needs. Machine learning algorithms predict optimal breeding times, health interventions, and management decisions. Some innovations aim explicitly at improving welfare. Automated brush systems allow dairy cows to scratch themselves, reducing stress. Enrichments like perches for chickens and rooting materials for pigs provide outlets for natural behaviors. These aren't revolutionary, but they acknowledge that welfare matters alongside productivity. Global ripples. The transformation of livestock didn't happen in isolation. It reshaped global diets, trade patterns, and environmental systems in ways that echo across the planet. Understanding these ripples helps us see livestock not just as farm animals but as key players in the global food system. A century ago, most people ate meat occasionally. It was expensive and locally produced. Today, global meat consumption has quadrupled. Chicken, once a luxury, is now the cheapest protein in many countries. This shift is directly tied to industrial livestock systems that produce meat efficiently and cheaply. Rising incomes in developing countries drive demand for animal products. As people move from poverty to middle class, meat and dairy consumption typically increases. This pattern played out across Asia, Latin America, and parts of Africa over recent decades. China's pork consumption alone accounts for half the world's total pig production. This demand surge required livestock systems capable of unprecedented scale. Industrial models developed in North America and Europe spread globally, adapted to local conditions. Brazilian beef, Thai chicken, and New Zealand dairy all follow variations of intensive production systems. The result is a globally interconnected livestock industry where feed ingredients, genetics, and finished products cross continents routinely. Trade agreements and market integration accelerated this globalization. Countries specialize in what they produce most efficiently, then trade. The United States exports pork to China and beef to Japan. Brazil ships chicken globally. New Zealand dairy products reach every continent. This efficiency drives down costs, but also makes food systems vulnerable to disruptions. The environmental impacts are substantial and growing. Livestock contribute approximately 14.5% of global greenhouse gas emissions, primarily from enteric fermentation in ruminants and manure management. Land clearing for pasture and feed crops drives deforestation. Water use for livestock and feed production strains scarce resources. Nutrient runoff from concentrated animal operations pollutes waterways. These impacts sparked pushback. Environmental advocates call for reduced meat consumption or shifts toward less resource-intensive proteins. Welfare advocates demand better living conditions for farm animals. Health experts warn about antibiotic use in livestock contributing to antimicrobial resistance. These concerns are reshaping consumer preferences and regulatory landscapes. Some producers are exploring alternative models. Regenerative grazing practices aim to rebuild soil health while raising cattle. Pasture-based poultry and pork systems reduce reliance on confinement. These approaches typically produce less per animal, but with smaller environmental footprints and better animal welfare. They also cost more, limiting accessibility. The tension between efficiency and sustainability, between affordable abundance and environmental limits, defines modern livestock farming. We've created systems that feed billions, but strain planetary boundaries. The next century must reconcile these contradictions or face consequences we're only beginning to understand. The next frontier looking ahead, livestock farming stands at a crossroads unlike any in its history. The forces that shaped the past century are still operating, but new possibilities and pressures are emerging that could transform the entire concept of animal agriculture. Cellular agriculture represents the most radical possibility. Lab-grown meat, produced by culturing animal cells without raising and slaughtering animals, moved from science fiction to commercial reality. Several companies now produce cell-cultured chicken, beef, and pork. The products are real meat at a cellular level, but grown in bioreactors rather than on farms. If this technology scales affordably, It could reshape everything. The environmental footprint could shrink dramatically. Animal welfare concerns would largely disappear. Land currently used for livestock could be rewilmed or but significant hurdles remain. Costs, consumer acceptance, regulatory frameworks, and the cultural role of traditional farming all pose challenges. Precision livestock farming will likely expand regardless of cellular agriculture's trajectory. Sensors, AI, and robotics will monitor and manage animals with increasing sophistication. Predictive algorithms will catch diseases earlier, optimize nutrition precisely, and manage reproduction more effectively. This could improve both productivity and welfare if designed thoughtfully. Breeding goals are evolving beyond pure productivity. Climate resilience is becoming crucial as temperature and weather patterns shift. Animals that maintain production under heat stress or with less water will be valuable. Disease resistance matters more as new pathogens emerge and antibiotic use faces restrictions. Longevity and robustness are gaining recognition as economic and welfare priorities. Alternative proteins from plants, fungi, and insects are capturing market share and investment. These don't replace traditional livestock, but create competition that could reshape demand. If alternative proteins become cost competitive and widely accepted, they could reduce pressure on livestock systems to scale further. Regenerative agriculture offers a different vision. Instead of intensifying production, some farmers are integrating livestock into ecosystems that restore soil health, sequester carbon, and support biodiversity. Cattle managed through adaptive grazing can improve degraded grasslands. Chickens following cattle can break pest cycles and distribute nutrients. These systems produce less per animal, but generate multiple ecosystem benefits. Policy and consumer preferences will shape which paths dominate. Carbon pricing could make high-emission livestock more expensive, shifting demand toward lower-impact proteins. Animal welfare regulations could ban the most intensive confinement systems, or efficiency pressures and cost concerns could maintain industrial models as the primary system. The ideal future probably combines multiple approaches. Industrial systems producing affordable protein efficiently alongside smaller-scale, regenerative operations providing premium products and ecosystem services. Cellular agriculture supplementing rather than replacing traditional farming. A diverse landscape where different models serve different needs and values. Unlike crop evolution, which often feels abstract, livestock transformation confronts us with direct ethical questions. These are sentient beings capable of suffering, not just biological machines. How we treat them reflects our values as a society. The past century prioritized productivity above nearly everything else. That focus delivered abundance, but created systems where welfare is often compromised. The next century must do better. We need livestock systems that respect both human needs and animal well-being, that produce food affordably while staying within environmental limits. Farmers face difficult trade-offs. Economic pressures push toward efficiency and scale. Welfare improvements and environmental practices often increase costs. Without supportive policies and consumer willingness to pay fair prices, change remains difficult. Blaming farmers for system-level problems misses the point. The entire food chain, from genetics companies to retailers to consumers, shapes what farming looks like. Scientists and breeders must balance objectives. Genetic selection can't optimize for yield alone. Welfare traits, longevity, and environmental adaptation need equal consideration. Technologies like genomics and gene editing offer powerful tools, but wisdom in deploying them is essential. Policymakers set the rules that govern livestock farming. Regulations around housing systems, environmental standards, and antibiotic use directly impact how animals are raised. Subsidies and trade policies influence which production systems thrive. Getting these policies right requires balancing multiple legitimate concerns. Consumers drive demand through purchasing decisions. Choosing products from higher welfare or regenerative systems, even at higher cost, sends signals through supply chains. Reducing meat consumption or diversifying protein sources can ease environmental pressures. But these choices must be accessible and affordable, not just available to the wealthy. The next century of livestock farming will be shaped by how we navigate these tensions. Technology will provide new tools and possibilities, but technology alone doesn't determine outcomes. Our values, choices, and priorities will decide whether we create livestock systems that nourish both people and planet sustainably. Recap: over the past 100 years, livestock transformed as profoundly as the farms that raised them. Cattle were engineered into milk and meat producing specialists, with dairy cows increasing output more than fivefold. Pigs and poultry shifted from backyard animals to the foundation of global supply chains, growing faster and more efficiently than ever imagined. Selective breeding rewrote their genetics, prioritizing growth and productivity, but sometimes compromising health and welfare. New husbandry practices and technologies enabled unprecedented scale and control, moving animals from pastures into industrial facilities. These changes rippled globally. Meat consumption quadrupled. Livestock trade became environmental impacts grew substantial. Now, as we look ahead, cellular agriculture, precision farming technologies, regenerative practices, and evolving consumer values are creating new possibilities. The future won't simply extend past trends. It will require balancing productivity with welfare, affordability with sustainability, and innovation with wisdom. If this exploration of how livestock evolved over the past century gave you new perspective, give this video a like and share it with anyone interested in where our food comes from and where it's headed. Subscribe to Farmtips Diary for more deep dives into agricultural transformation, and hit that notification bell to catch every new video. Thanks for watching, and we'll see you in the next one.